Welcome. This is the IoT-based hospital patient learning device, or Team A28. Our project focuses on diminishing missed patient appointments in hospital and doctor's office settings. We have developed a cloud server and doctor-facing front-end interface that allows doctors to schedule appointments with patients. Patients are given appointment date and a device, which will send them reminders about their appointment. Patients will be prompted to tell if they are going to attend the appointment through a yes or no prompt. If patients choose yes or no, the doctor will be able to know this response in real time and prepare accordingly. This hopefully will reduce no-show in hospital clinics and additionally reduce loss and waste. Requirements and design constraints for the hardware side, or that it was simple to use, that it would cost less than $40 a unit, and would have a minimum of a 7-day lifespan. Low data transmission rates and a Wi-Fi connectivity in absence of the cellular connection allow us to fulfill these constraints. The software main requirements are that the software is password protected for user accounts. We've developed an API for device server integration, real-time user notifications, and that the software is available online 24/7. Additionally, we have implemented HTTPS security features. The main constraints include page responsiveness and the ability to view the software on any kind of device, small, medium, large, or even tablet size at the appropriate pixel count.
The design approach for the electronics is that our device must be battery powered and rechargeable. We have interactive peripherals, and we have multiple ways of communicating over the internet. Figure 2 shows a simplified block diagram of all of the components on our device, and Figure 3 shows the final device PCB that we created. In Figure 4, we see the terminal output from a device wake cycle. Our device firmware was written in MicroPython using mostly custom modules, and we have configurable settings built into the firmware for users to change.
Regarding our software, to develop the user interface, we use the Bootstrap 4 framework, as well as pure HTML, CSS, and JavaScript, which overall gave us cross-browser compatibility and a responsive frontend, as you can see on Figure 5. While regarding the backend, our software uses a client-server architecture, and we developed the backend by using Django, which is a Python web framework, which gave us the opportunity to quickly develop and implement the backend features that we wanted. One of these features was the API through which the patient devices and the web server communicate to each other using JSON, as you can see on Figure 6. And another complex feature was the implementation of real-time notifications for the doctors, where we modified the normal HTTP cycle to allow asynchronous WebSocket connections between the clients and the server. Lastly, we deployed our platform for testing on an AWS EC2 machine as a collection of containerized microservices by using Docker.
So testing the hardware, we were able to have an average of 16 seconds appointment response time from picking up the device to putting it down again. The average message size sent from the device was 1.2 kilobyte. So we are using less than 36 kilobyte of data in a day. And our device lasts for 11 days, although this value was calculated and was not tested.
We used several methods to test our software, which were unit testing, integration testing, and system testing, which helped us verify programmatically and manually whether the patient device and the server communicated with each other correctly. And after senior design, we also hope to do a user acceptance testing that will involve the clinical trial to test the software on real doctors and patients.
To summarize, the patient no-shows in the medical field create a huge amount of loss and waste for doctors and for hospitals. The project in general was successful, although we were unable to complete a clinical trial regardless of the partnership that we had with a dermatology clinic. We hope to have completed a clinical trial within the next couple months.